Hi everyone, your GCSE chemistry exam is around the corner. This is your quick final revision. We are going through 10 key questions you should definitely know before the exam. Pause the video and try each one before I explain it to you. The first question says, a particular atom of magnesium contains 12 protons, 12 neutrons, and 12 electrons. Write down the mass number of this magnesium atom. We know the formula for mass number, which is number of protons plus number of neutrons. Over here we have 12 protons and 12 neutrons, so the mass number is 24. Let's move on. Complete the following sentence using two words. Isotopes are forms of same elements that contain identical numbers of dash but different or differs in numbers of dash. Alright. So isotopes, we know they have identical number of protons, means same atomic number but different mass number, so differing number of neutrons. Next, explain briefly why different isotopes of an element show the same chemical behavior. So the chemical behavior depends on the number of arrangement of electrons, and they have same number of electrons. So 1 mark for the same number of electrons and the chemical behavior depending upon the number of arrangement of electrons. Next, isotopes have the same number of electrons because they have the same number of protons as well. So this for another 1 mark. It's a 2 mark question, therefore we need 2 strong points for it. Question 2. As you move down group 1, the reactivity of the metals increases. Give 2 observations you would see when a small piece of potassium reacts with water. When a small piece of potassium is there, it moves around on the surface of water. So about potassium, I'll tell you few points. You can take any 2 if you want. It moves around on the surface of water. Second can be a lilac flame is produced. Lilac flame is produced. Potassium dissolves or disappears. Fourth, fizzing bubbles can be seen. Fizzing or bubbles are seen. Why are they seen? Because hydrogen gas is released over here. Alright, so we have 4 points over here, 4 strong points. Any 2 you can memorize and write it down for this answer. Moving on. B. For group 7 elements, the halogens state the color at room temperature of these. So fluorine is pale yellow. Bromine is orange brown. We usually see brown gas or brown colored gas evolved if in a reaction bromine is being produced. So orange brown or red brown, anything will go. Next, helium and neon are both in group 0. Explain why these elements almost never form chemical compounds. Group 0 elements, what do they have? They have full outer electron shell. Full outer electron shell. And this makes them very stable. 2 mark question, very stable. And they have no tendency to gain or lose or share electrons, and therefore they never form chemical compounds. Sketch a dot and cross diagram to illustrate the ionic bonding in magnesium oxide. Show only the outer electron shells. So let's see. First we have magnesium and over here oxygen. Atomic number for magnesium is 12 and for oxygen it's 8. So how many electrons in the outer shell? For magnesium it's 2 and for oxygen it is 6. The question says specifically only the outer shell electrons. So this is 2 plus and this is 2 minus. Now what will happen? Magnesium wants to lose 2 electrons and oxygen needs 2 electrons. So it's 6 represented in this manner, and dot and cross it is specifically, so we'll show it with the cross, which is lost by magnesium and gained by oxygen. All right, so this is how you can represent the dot and cross diagram for MgO. Next question. List 2 physical properties that are typical of substances with joint ionic lattice structures. Again, there are many. We have high melting point. It is a conductor of electricity, conducts electricity. Then these are brittle in nature when hit. Also hard. So these are 4 physical properties. You can list any 2 from these. Let's move. A student uses carbon rods as electrodes to electrolyze a solution of copper chloride. Which substance will be released at the positive electrode, which is anode? Use your knowledge of the reactivity series to justify your answer. Now, reactivity series suggests what? Highly reactive metals. Highly reactive metals and least reactive metals. Least reactive metals. Highly reactive we have potassium, sodium, calcium. All right. Least reactive we have aluminium and others. So for the first part we say over here we have copper, Cu, and Cl, which is negative, Cu as positive. We are talking about the positive electrode, which is the anode. So chlorine gas Cl2 will be released at anode. Why? Because in the reactivity series, chloride ions are more easily oxidized than the hydroxide ions when the solution contains chloride. Therefore, chlorine forms instead of oxygen at the positive electrode, which is the anode. Next, write half the equation for the change taking place at the negative electrode, which is cathode. So at cathode, what will happen? Cu2 plus ions will be there. So Cu2 plus in aqueous form plus 2 electrons will give Cu, which is copper in solid state. Where do we get these 2 negative electrons? From the negative electrode, which is cathode. Next, C. What visible change would the student notice at the anode during this experiment? So at anode, what is happening? Chlorine gas is produced, or chlorine gas is released at anode. Chlorine gas is released at anode. Therefore, bubbles of the gas will be seen. Will be seen. Also, the solution may change color or bleach the indicator paper. Next, explain why copper chloride must be dissolved in water or melted before electrolysis can happen. Why do we do this? Because we need the ions to move freely. Move freely. The ions must move freely, or the ions must be free to move. In a solid ionic compound, ions are fixed in the lattice and cannot move. Therefore, we need them to be dissolved in water or melted before electrolysis can take place. Alright, let's move on. Question 5. Arrange the following metals in order of increasing reactivity. Put the least reactive first. Now it says put the least reactive first, means over here at the top, and then the most reactive at the end. So first we have magnesium, gold, zinc, calcium and iron. You should remember the activity series very well for this. Gold is less reactive, so we'll write gold first. Next comes iron. Next zinc. Then it's magnesium. And after that it is calcium. So as per this, calcium is the most reactive and gold is the least reactive one over here. Alright, next. In the blast furnace, carbon is used to extract iron from iron ore. Describe why carbon is able to remove oxygen from the iron ore. So carbon is more reactive than iron. Therefore, carbon displaces, these words are to be there in your answer. Carbon displaces iron from its ore by combining with oxygen to form carbon dioxide and leaves behind iron. So iron is left behind and CO2 is made. Therefore, carbon is able to remove oxygen from the iron ore. Suggest why carbon cannot be used to extract aluminium from its ore. So over here what is happening? Aluminium is more reactive. Aluminium is more reactive than carbon. Therefore, carbon cannot displace aluminium from its ore. Carbon cannot displace over here. Over here what was happening? That carbon was more reactive than iron. Over here aluminium is more reactive than carbon. So carbon cannot displace aluminium from its oxide because aluminium holds on to oxygen more strongly than carbon does. Therefore, we do not use carbon for the extraction of aluminium from its ore. A pupil makes a pure dry sample of zinc sulfate crystals by reacting zinc oxide with dilute sulfuric acid. We have to write a balanced symbol equation for this reaction. So first we'll write the reaction and then we'll balance it, or we'll see if it's already balanced. So zinc oxide is ZnO plus dilute sulfuric acid H2SO4. H2SO4 in dilute form. It will react to give ZnSO4, which is the salt, plus H2O, liquid. This is not a precipitate, so we'll write it is in aqueous form. Now let's see if it's all balanced. How to check if the balancing is done or not correctly? So we have zinc, metal. Then is there any non-metal? Yes, sulfur and sulfur over here. Now we'll check hydrogen. It's 2, and oxygen, how many in total? 4 plus 1 5 and 4 plus 1 5. So this equation is already balanced, need no balancing. Next, describe the series of steps the pupil must follow to obtain dry, pure crystal, starting from the mixture after the reaction has finished. Your descriptions should include terms filtration, evaporation, and crystallization. Now, specifically, if in your question you do not get these words as well, or the question doesn't say that your description should include these, you should write these in your answer, because these are the keywords. Over here in the question I've clearly mentioned to mention these words. First, we'll talk about filtration. What is filtration? In filtration, we pour the reaction mixture through filter paper and the unreacted zinc oxide remains on the paper. The zinc sulfate solution passes through as the filtrate. So we have zinc oxide which will be on paper, on filter paper, whereas ZnSO4, which is the solution, it will pass through as filtrate. Alright. Next is evaporation. Second, evaporation. Evaporation is when we heat the filtrate gently to remove some water and make the solution more concentrated. Until when? Until crystals start to form at the edges. So what is the filtrate? The filtrate is ZnSO4, which is zinc sulfate. We'll heat the filtrate gently to remove some water and make the solution more concentrated. Next is crystallization. Crystallization is when we leave the concentrated solution in a warm place to cool slowly. Over here, when it cools slowly, we'll see crystals of zinc sulfate. Crystals of zinc sulfate will be formed as the water evaporates. Last step over here, the fourth step is drying. Although it's not mentioned over here, but it's a 4-mark question and we have to include all the 4 steps. Drying is when we remove the crystals from the remaining liquid and pat them dry between filter papers or leave them in warm open. So each of these 4 steps is of 1 mark and the total question or the total answer will be of 4 marks. Next question. Fill in the missing words. A strong acid is one that dash completely when dissolved in water. So what does it do? It ionizes, or you can say dissociates. Any one of these. A strong acid is one that either you can use the word ionizes or dissociates completely when dissolved in water. Both hydrochloric acid, which is strong, and ethanoic acid, which is a weak acid, are made up at the concentration of 0.5 mole per decimeter cube. The ethanoic acid has a higher pH than the hydrochloric acid. Explain why. Over here we have a strong acid and we have a weak acid. We have to see that if both are made up at a same concentration, then why ethanoic acid has a higher pH? So the answer is hydrochloric acid is so strong, so it releases all its hydrogen ions into the solution. Whereas ethanoic acid is weak, so it releases only a small fraction of the hydrogen ions, resulting in a lower concentration of H+, and therefore it has a higher pH. Both hydrochloric acid and ethanoic acid are made up at same concentration. The ethanoic acid has a higher pH than hydrochloric acid. Why? So we have to give 2 strong reasons for the same. Hydrochloric acid is a strong acid. It's a strong acid, it means it dissociates or ionizes completely. It releases all its hydrogen ions into the solution. Whereas ethanoic acid is a weak acid. Therefore, it releases only a small fraction of small fraction of H plus ions. Therefore, it results in a lower concentration of H plus ions in the solution, and therefore it has a higher pH. Higher pH for ethanoic acid. Give one example of a strong acid and one of a weak acid. Over here in the question only you saw that it's given to you hydrochloric acid and ethanoic acid. If not, also strong acids are usually hydrochloric acid, sulfuric acid, H2SO4, nitric acid. So anyone you can write. For weak acids, you have organic acids like ethanoic acid, you have citric acid, then you have carbonic acid. All these are weak acids. Let's move on. Calculate how many moles are present in 6 grams of carbon atoms. The relative atomic mass of carbon is 12. How do we calculate it? Moles equals mass upon the relative mass. So we have to find moles over here. The mass given is 6 and the relative mass we know is 12. So 6 upon 12, which is 0.5 moles. Alright, easy. A solution contains 0.20 moles of potassium chloride dissolved in 250 cubic centimeter of water. Work out the concentration of this solution in mole per decimeter cube. So we have volume. First of all, we'll convert the volume in cubic decimeter, which means 250 upon 1000, which makes it 0.25 cubic decimeter. Now concentration. So for concentration we have the formula of moles upon the volume. How many moles we have? 0.20. What is the volume in decimeter cube? It is 0.25. So if we solve this, removing the decimals, we get 4 upon 5, which is 0.80 mole per decimeter cube. Okay, this is how we do it. Next, write down the mathematical relationship that links mass, moles, and relative formula. So, mass equals moles times the relative mass or the relative formula. Or you can write moles equals mass upon the relative mass, the relative formula, any one of them. Question 9. A student starts with 12.5 gram of copper oxide and reacts it with excess sulfuric acid in the theoretical maximum mass of copper sulfate that could be 25 grams. The student actually collects 18.8 grams. Now numbers are very important over here. So the student starts the reaction with 12.5 grams of copper oxide and reacts it with excess sulfuric acid. The theoretical maximum mass of copper sulfate could be 25 grams, but the student is actually collecting 18.8 grams. First question is, compute the percentage yield for this experiment. Give your answers in 2 significant figures. Now it's a 3-mark question. First of all, the percentage yield formula is actual yield upon the theoretical yield times 100. So what is the actual yield? 18.8 grams. What was the theoretical yield? 25 grams. Times it by 100. So 18.8 upon 25. We'll remove the decimal point if you want. Solve it like this. Now you have 188 upon 25, which is 75.2%. The question specifically states that you have to give the answer in two significant figures. So the final answer, what you're gonna write is 75% is the percentage yield. Over here, 1 mark is for the correct formula writing, another is for correct substitution, and the third mark or the final one is for your correct answer in two significant digits. Suggest two possible reasons why the actual yield is lower than the theoretical yield. So, any two reasons you can write, I'll give you many. First is reversible reaction. Reversible reaction. The reaction did not go to complete completion, that is why. Next can be product lost during filtration, transfer, crystallization, any one of the process. Third can be impurities in the starting material. Then last can be the human error. Human error. Because not all product is corrected. Therefore, any two among these four you can write it in your answer. Last one. In industry, why is it beneficial to use a reaction with high atom economy? High atom economy produces less waste, which is better for the environment and reduces the cost somehow. So you can write more sustainable, you can use the words like more sustainable or less raw material, less waste, more sustainable, less raw material, any one. These are the keywords. Any one thing if you write in your answer, explain, you'll score marks. Moving on to the last question. The reaction between sodium hydroxide is NaOH, and dilute hydrochloric acid, HCl, causes the temperature of the mixtures to rise. Classify this reaction as exothermic or endothermic. Now the question clearly states the temperature is rising, means it is an exothermic reaction. Temperature rises in exothermic reaction, and it means heat energy is released. Draw a labeled reaction profile diagram for an exothermic reaction. Your diagram must show energy level of reactants, energy level of products, activation energy, and overall energy change labeled as delta H. So I'll show you how to draw it. First we have y-axis. Over here on y-axis we have energy in kilojoules per mole. On the x-axis we have extent of reaction. Follow the steps and you will find it very easy. Now we'll draw one horizontal line and label it as reactants. Then put a curve and then again down and again horizontal line. Because this is an exothermic reaction diagram, so there will be lower energy than reactants. Label it as products over here. Now we'll make this part dotted, over here this part, and over here this part. This curve over here, this is your activation energy, EA, and this is the transition state. This thing is the overall energy change, so label it as delta H, which is negative because this is an exothermic reaction. So just label it as exothermic And you are done with a well labeled reaction profile diagram for an exothermic reaction. It's a 4-mark question and you have labeled all 4 parts, so you'll get 4 full marks. 1, 2, 3, and 4. So that's your final quick revision before your GCSE Chemistry Paper 1. Focus on what you know, don't panic over what you don't, and keep practicing past questions. Stay calm, trust your preparation, and go in with confidence. We have got this.